This video discusses repetition with while loops and for loops in Python. We'll first review Booleans and code structural components, and then we'll talk about the Python syntax for while and for loops, the range function, and os.listdir. First, go ahead and get a pencil out and jot down answers to the questions you see on this slide. What are the logical operators? And is one of them. What are the comparison operators? Some of them are listed here. Which of the following are true expressions in Python? And which strings, lists, dictionaries, and tuples are evaluated as false in Python? Pause the video now, because next we'll discuss the solutions. The logical operators are and, or, and not. The comparison operators are less than, greater than, less than or equal to, greater than or equal to, not equal to, which uses the exclamation point, equals, and the equal to comparison, which uses a double equal sign. The true expressions in that list are B, D, and E. A is obviously false. B is true because it's a non-empty list, even though it's full of false items. C is false because if you subtract subtract 11 over 2 from 5 in Python less than 3.0 level Python, the integer division will give you a 5 for the second part of that equation because it will truncate the remainder. So that means this will evaluate to 5 minus 5, which is 0, which Python, evaluated as a Boolean expression, will return false. So if you say BOOL parentheses 0 in parentheses, you will get false as a return value. D is true, even though the built-in constant is true. This is a string. This is a non-empty string with the value of none. E is also true, again a non-empty string. F is false because it's an empty list, and G is false because it's the constant none, which evaluates to false. It's one of the 7 things in Python that are considered to be false. To answer question 4, empty strings, lists, dictionaries, and tuples are evaluated as false. The responses to this question are also replicated in the notes page of this slide. Before we move on to the syntax for looping in Python, let's review the pseudocode keywords. So we keep in mind that looping is one of several structural components in Python. Match the pseudocode words in the right column with the structural component on the left. As you do this, keep in mind that any word that definitely doesn't fit in with numbers 2, 3, or 4 will fall into the more general sequence category. So for example, end proc goes with number 4, whereas decrement would not necessarily be used with any of 2, 3, and 4, so that's a sequence. It might be used inside of repetition, but it's not necessarily required there. Go ahead and write down your responses for the items that would fit into numbers 2, 3, and 4, and then we'll assume that the remainder go into category 1. Now we'll discuss the responses. End proc is number 4. Else if is number 2. End while is number 3. If selection, number 2. Reading through the next few. Then is a selection keyword, number 2, because it partners with if. 4 is a repetition keyword. Return is a procedure keyword. That's the case where your procedure does something and computes something for you, for example, and returns the value that it computes. Proc is procedure keyword. While is for repetition. Else for selection. End for repetition. And end if for selection. I believe we haven't missed any. Then the remainder of the words are sequence words. You can check table 8.2 for a listing of those keywords and descriptions. You can also find a script that I use to randomize the order of the matching list in the notes page of this slide. One thing that came up was that using the word while and kind of how we use it in casual, like talking about concurrence, right? So I'm listening to music while I'm writing my paper, right? No, we don't use it in code that way. While is really used for while something is true, do the specific thing, okay? That's really the only thing that it's used for. It's to test a condition and then do things while that's true. So while x is less than 9, print x, okay? And then update x. And then it goes up, so what it does, it would say, all right, first of all, x is 0. So we go inside here, yep, right? Condition is true. Print 0. And it would set update, increment x, set it to 1. Go in here, is it true? Yup. Right? Print it. Update it. Yeah, 2. Yeah, right? And so what would this exactly print out? 0 through 8. Notice the use of indentation. That's required syntax. And colons. Colon at the end of that while statement. That's required. If we say we got rid of any of these one things, we're going to be in trouble. We got rid of the x equals 0. What would happen with this code? It depends, right? It could not print anything, or it could throw an exception. In what case would it not print anything? Well, we'll start with the exception. In what case would it throw an exception? What kind of exception would it throw? It would say to you that it's undefined. Yes, it would say to you that it's undefined. But that would be because x had never been defined. But if you're in Python 1, if you're in a session where you've defined the value before, say somewhere in another script you define the value of x. Whatever that last value was, it's still going to retain that. So if you run this code while x is less than 9, and the value is, what value of x would make it not print anything? Yeah, anything. So it's x equals 10, for example. From your last script that you ran where you had an x defined in it, then your code would run and it would just silently not print anything. It's really important if you're using a while loop to initialize your looping variable, and usually nice to do it right before the loop starts so you can see that. You need to have a condition, something that you're testing, some Boolean expression in here, something that can be true or false. What about if we take out x equals x plus 1? If we have the x equals 0 back in there, that's there, and x equals x plus 1 is missing. Yeah, it'll keep printing 0 ad nauseum. What do you call that? An infinite loop. Keeps going. And you need to be able to stop your code running, which I have that on another slide.
Is there an infinite loop just for x equals x plus 1, even though it's not going to print anything greater than 8, but it's going to keep adding x each time and then running back through that while?
No, so what happens if all of these things are intact? It'll change x to 1, and then it'll change x to 8, right? And it'll say 8 less than 9, print x, x equals x plus 1. X will become 9, and then it'll say while x less than 9, it'll test that condition, it'll fail, and then it'll move on to the next line of code that's after that, and it's done with this. It'll jump on to the next thing that's going on. Good question. Just keep in mind that if you're using a while loop, you need to initialize that conditional statement and check some condition and do an update of some kind. Otherwise, bedlam. To apply while loops to geoprocessing problems, you need to include the same components. Here's an example which creates 3 rasters containing random values with a normal or Gaussian distribution. We start by importing ArcPy, setting our workspace, setting up our output directory file path, and then setting overwrite output to true so that we can rerun the script and not cause errors. Then we check out the Spatial Analyst tool because we're going to use Spatial Analyst to create the normal rasters. Line 11 has our first component. We want to set the counter to 1 to start with so that our first raster that we create will have a name that is appended with the number 1. And then on line 12, we test our condition. So this is why we were reviewing Booleans at the very beginning of this lesson, because right here, n less than 4 is a Boolean, which is either true or false, depending on the value of n. At first it's true, because n is 1. While n is less than 4, we go inside and do the steps that are shown here. We set the output name. We're using the string format function to do that. We call the create normal raster tool, and then we call this save function on that raster object that it returns so that it will be saved in the output directory that we've specified. We're doing concatenation. Notice that the output directory that has a slash here, so when we join those together, it will be the output directory slash the file name. And then we print out a report that this has been created. And finally, before we dedent to end the loop, we increment the value of n. So n equals n plus 1 adds 1 to the current value of n. So after this statement executes, 1 plus 1 will be 2, and the value of n will be 2, and we'll come back up here, test whether n is less than 4, so therefore we will go inside and create output raster number 2. And so forth until we get through this again with n equal to 3, and when n equals 3 we get down here and n becomes 4 because 3 plus 1 is 4, and we check our while condition again and it fails. So next the code will go down to here. It'll delete our raster object, which we were just overwriting in memory in this case since we weren't deleting it inside the loop. And then we'll print a final completion statement to let us know that the file has completed. So the output from this will be 3 files, out1, out2, and out3. They'll be Esri grid rasters. And we've included our 3 components on lines 11, 12, and 17. Notice certain lines are placed inside the loop and others are out. of course, the initialization of the looping variable n needs to come outside of or before the loop. Otherwise, we would set our value back to 1 every time we got inside the loop, and we'd again have an infinite loop. Notice that we also put the lines 6 through 9 outside of the loop. We put them there because they only need to be done once. You could put them inside the loop without any harm to the functionality of the code, but the code would be a lot less efficient because you'd be needlessly running each of these lines over and over. Line 13 is inside the loop deliberately. That's because it's changing. It's using n to create the output file name, which means that we will have a unique file name for each of the output files. Otherwise, how would we have a unique output file name? It's got to be based on something that's changing inside of the loop. The n equals n plus 1 has to be indented with the rest of the code. If it were dedented, the incrementation would not occur inside the loop. That's another way to create an infinite loop. We chose to put the deletion statement, line 18, outside of the loop because it doesn't have to be inside the loop. What we're doing with this code is we are overwriting that temporary output raster each time we do this, and once we're done with it, we're releasing it. Looking at this example, you may be thinking, well, you're only creating 3 outputs, so why bother with this complicated while loop? Maybe so, but you're still going to have a lot of repeated lines of code, so your code will be more difficult to discern. And of course, this is a simple example where you only need 3. So think about which lines of code you'd need to repeat. Say if you had 10 output files you wanted to create, you'd have to repeat lines 13, 14, 15, and 16, but also line 18 because you'd be creating a temporary raster, or you may be reusing that temporary raster again. That would be okay as well. But you'd certainly at least have 4 lines that would have to be in your code every time you created a new raster. Also, that assumes that you know ahead of time how many rasters you need to create. So say the number here, number 4, were instead given by user input. Then you wouldn't know ahead of time, and you wouldn't be able to hard code a set of output names and a number of commands that would be correct. So this demonstrates the power both in making your code very clean and easier to read, and in terms of making it flexible, of using block structures like the while loop. On to the slightly less intuitive, but once you know it, very cool for loop. In other languages, in for loops, you explicitly do the same thing you do in a while loop. But in Python, in a for loop, you just have something that you're running through, that you're iterating over. That means running through, pointing at each individual thing one after another. And you do it this way. Use a for keyword and the in keyword. Those are always used together. And there's always something in between the for and the in. And that something is a variable that you make up then and there on the spot, a variable name. And the thing that comes after the in is something that you can loop over. For example, a list has a sequence of items in it. And so you can point to the first one, point to the second one, point to the third one, point to the fourth one. This code will just do this. It'll print those 4 things that we have in our list sequence. So the file, there's no code that's missing here. This is the entire code for this. The file is defined right here inside here, okay? I don't set that variable up beforehand. It automatically sets it to the first thing. So usually it's a good idea to use a name that's not already being used in your code, because using it here is going to change it. After this loop runs, the file's value is data4.shp. Just a comparison between while loops and for loops. In while loops, you have to initialize that variable. You have the keyword while and an expression, your code statements, and you update the variable. In for loops, you have an iterating variable, the one that gets updated, and then you have a sequence after the end keyword. So the sequence can be a list or a string or tuple, and then you have code inside of here. Generally speaking, you want to use that iterating variable inside your loop. That's why you're doing it. If you're not using that iterating variable, probably you're doing something wrong. Inside your loop there, you need to use it. Sequence, I said, it's a sequence. So it consumes lists, strings, tuples. You could, no, I'm not sure why you'd want to, but sometimes you might want to loop over a string, right? Anything that's indexable. So you can say my string equals GIS rules and say for each letter in my string, print, I'm sorry, this should say print letter. This is what would print. GIS space RULES. So it's iterating through, it's pointing at each one letter at a time, one character in the string. To have some data in your list, maybe not hard-coded, maybe you get it from the user, maybe you get it from listing the files in a directory. This is how it works. It updates, it has an internal cursor pointing at the things in the list. When you first enter the loop, it points to the first thing in the list. When you get to the end of the code that's inside the loop, it goes back up and updates and moves that cursor to point to the second thing in the list. And then it goes through the code that's inside, and it automatically updates the cursor once it's done to the next one and to the next one. It helps if you think of it this way. You think of it as going along and pointing to each thing in the sequence. Can you write a while loop that's equivalent to this for loop? Oh, try to just write the code down that's in the number 2 and change the numbers. Go through like you're a computer and think about what exactly it's going to print. So it'll print 5. So when it's 20, it'll say x less than 20, and so it won't print 20, right? But this one actually does print 20, right? Because it's going to say the for loop is going to print 20. It's going to go through that entire list. So you need to change your, you could do it that way. That would, or what's another way to do it? Just using the number 20. Use a different comparison operator. Yeah. Mm-hmm. For the for loop, you have to have some kind of sequence to iterate over beforehand. For the while loop, you don't. So now we're doing Python code. So this is pseudocode. So you can just take that line out. And this is all lowercase. Is that right? I can't tell with your bubbly writing. And remember your. Good. So for this one, make it look just like number 2, except use different numbers. Okay. This is right. Okay. Although it needs to be at the same, I guess it started out to be at the same indentation. Okay. All right. You're missing a That's something at the end of this line. And printing is good. Now, this third step should be changing the value of x. So what you want to do is you want to change it. When the first time it's 5, you want to change it to 10. But the second time, you want to change it to 15. And the third time, you want to change it to 20. So what way could you do that with one line that would, each time it would take the current value?
Are you supposed to make this a list?
No. For the while loop, you don't need a list.
Right.
So you can actually use one statement like this one, but slightly modified. So what does this statement do? It takes the current value and adds 1 to it and sets that new value there. So you can do the same thing for the problem that you're trying to solve, except in this case, you want it to not update by 1. You want it to update by every time. If you finish the first one, try the second one. Yes. Okay, let's see. Yep, that looks right. The only thing that I would say, I'm a little confused about your indentation here. So this one, is this indented?
Yes.
Oh, no.
Yes.
You want the four to be at the same
Okay.
as the noob.
Gotcha.
The statement that starts with 4 should not be indented. The stuff that's inside of it should be indented. And is this a lowercase f or an uppercase f?
That's a lowercase f.
You're going to have to work on that one for your exam.
Because an uppercase is going to look like that.
Yeah. And how does that not
It
look
has a
like
curve.
that? We need more curve action. Make it real clear. Perfectly clear, and maybe.
I have to be careful. I'm left-handed because then it's going to turn into a P.
Hey, I'm left-handed too, and my scribble is somewhat readable. I'm assuming you got, okay. This looks to me like a big F. So I'm going to say the same thing to you. Something like that. And some of you had while x is less than 21. Would that work? Yeah, that would also work. That's just another way to do the same thing. Would x is less than 26 work? No. All right, you've got to watch your boundary cases. And this one, yeah, you got to write a list out for that for loop. You don't have to write a list out for the while loop because your while loop is generating, it's updating. You have to have this update statement so that it moves on. The thing about this is, okay, it's kind of just about manageable to type in the numbers 0 through 8. But if I said, make a list from 0 to 100, so the built-in range function is useful if you need to look through a list of numbers. The range function can take one argument, it'll give you a list from 0 to 5, right? It's exclusive on this end. And if you give it 2 arguments, it'll start with the left one and end just below the right one. If you give it 3 arguments, then you can jump more than one at a time. Try writing this with a for loop, but replace nums equals 0 through 8 using the range function. So it should just be range of, you can do it that way. You could do 0, 9, 1, or you could do just range 9. Yeah. Okay, replace this while loop with a for loop using that range function. Yes. And no ambiguity on your upper and lower. That's good.
Makes sense, yeah.
It could look just like this. You can put that range function right inside there if you need to. Or you can set a variable. Either way. Everything is fine with either one of those. Just summarizing, the for loop takes care of these 2 steps for you, right? It's doing that. It initializes the variable. It updates it automatically. Here's an example using a for loop for geoprocessing with ArcPy. So we have our standard setup, import ArcPy, set the workspace, the output directory, and the override output property. Next on line 9, we have a set of hard-coded file names. The loop itself, starting on line 10, is going to repeat through this, all the steps that are in lines 11 through 16 for each of these file names. So when we go into the loop, the first time we get to the loop, current file is automatically set to the first string in this list, data1.shp. Then we are removing the file extension using slicing on line 12. So base name will be data1. On line 14, we're creating an output file path using a different output directory than the workspace. We put the output directory path first. If we were just using our current workspace, we could omit that. Then we have the base name, which we set up on line 12. And the first time we loop through, it's data1. And we're appending line.shape. So we're calling the points to lines tool on the next line. So we want our data to be named the same thing as the input file, but with the word line added to the end of the file name. Now it's not the very end, and that's why we had to strip off the extension. Notice that that output name is going to be unique for each output file, and that's because we are using the iterating variable to inform that value. We're using current file to set the base name. So this base name will change each time, and therefore we won't be overwriting the same output every time. We call the points to line data management tool on the current file and pass in the out name for the output file name. And then we print the results using the format statement. Here's another example of geoprocessing with a for loop. In this case, we're using only one input file, but we want to buffer the input file over a different set of distances. So we want to vary a numerical value as we go through this process. Therefore, we wanted to vary the distance value from 1 mile to 5 miles, 5 different values. So here we use the range function, ranging from starting at 1, and because this value is not included, the value will stop at 5. So the range 1 to 6 will give us a list including the numbers 1, 2, 3, 4, and 5. That means that when we go into this loop, the variable num, the iterating variable, will first take on the value 1, and then the second time through the loop it will have the value 2, and so forth on up to 5. First time we go through the loop, line 11 will set the distance variable to 1 miles. It doesn't understand grammar, so it accepts 1 miles when 1 mile is really correct. The next line, 13, is using a different technique to create the output file name. We're still concatenating with the outdir, since we're setting our output workspace as something other than our input workspace. And this one is using formatting, string formatting, to add that number value onto the end of the name. So this will create, the first time through, this will create a file in C, JIS540 Scratch named buffer1.shp because we're using the iterating variable as a value to pass into here. So this will create buffer1, buffer2, so forth. And we call the buffer tool and report the results. Let's look at this one. Import OS, and it gives you OS module access. So you can do this. If you wanted to, say, loop through and do something with all of those files, you could use that list that it returns. Does it work for file geodatabases? It doesn't work in the way that our catalog lists things. It'll list the files that are inside of that directory, but it'll give you this, which is probably not what you were going for. Does it list subdirectories? No, but there is a function for that. And there's also a function for listing files in a geodatabase, which we'll not be getting into this time, but it'll be next time. Let's look at this in-class exercise linked to today's lesson. The goal of this exercise is to print the DBase shapefile and ASCII text file names found in a directory with an emoticon that goes with each. So here the DBase file has a O face, the shapefile has a smiley, and the ASCII text has a frowny face. All of this printing in our examples is really a stand-in for more sophisticated geoprocessing or other steps that you might want to do with particular data files. But for now, we need to focus on the general structure and how to get the code going before we fill in the details. The idea is that you loop through a directory and then make decisions about what you're going to print based on the extension of the file. When you start this exercise, first thing you want to do is use the os.listdir function to list the files in the directory. Get a list, return that list into a variable, then loop through the list and print the files as you loop through. First, get that working before you worry about which type of file it is and which type of emoticon to print out. Just print the file name. Usually this is the way you want to work through problems. In fact, sometimes you want to write pseudocode, then start writing code, and the pseudocode should maybe not be in as much detail as you need for the actual implementation. But usually it's a good idea to get the basic looping going first and then fill in the details once you have that. So once you get steps 1 through 3 working, use conditional statements because you're going to make a decision inside of the loop as to whether or not you should print the name out and what kind of emoticon to print with it. Print the emoticons as specified here. You can use the chapter 10 sample data to test this script. Note that this requires some old things that you learned. Remember the string function that you can use to check if it ends with a particular string? That function returns true or false. So it can be used in a conditional statement because it is a Boolean. Once you get this going, you might want to add an extra wrinkle. Print out not only the file name, but also the index in the list where it occurred. So in this example, 3.dbf was the third, because it's 0 base, 0, 1, 2, item in the list of files. Pause here to try this exercise. Next, we'll go over the solution. To solve this problem, we used os.listdir to get a list of files in the directory that was input by the user. Once we got the list, we can loop through it. You can use any variable name here that's not already being used. F will take on the name of the first file when we go in the list the first time, and it'll get updated to each of the names in the list. Inside, in a nested fashion, the conditionals, our testing conditions, have ends with, the string method that checks if a string ends with a particular substring that you pass in. And so we're checking if it's .shp else, we're checking if it's a .txt, else we're checking if it ends with dbf. What happens if the file extension is something else, say HTML? Nothing will be printed, no activity will be done for that. It will simply check all of these conditions and move on. When we get to a file that ends with a .shp extension, we print the name and a smiley face. Once we reach that point, the other two branches won't be checked because these are elifs. So if this condition is true, then it just goes on back up to the top of the loop and moves on to the next file. In our modified version, we're using a counter to keep track of the index in the list. Soon we'll learn another method for getting the index of an item in a list, but for now we'll just keep an extra variable which we initialize before we go in the loop as 0, and then we're printing that variable. Notice we're casting it to string so that we can concatenate it with these other string items. Down at the end of the loop, we're incrementing that so that, well, otherwise, if we didn't do the incrementation step, we would just always print index of 0 every time. So we want to keep track of the count, so we increment it by adding 1 to the current value, whatever that is, gets 1 added to it, and then when we go through it again, it'll have the right number in there, even if the number is not being printed out. This slide contains nested conditionals inside of a for loop. In this example, we'll look at nested looping, a for loop inside of a for loop. Suppose you want to print a workday week planner, like what's shown on the right. It has 4 weeks, and each week has the first letter of the day of the week, the days of the week printed out inside. To express this in pseudocode, we need to think of the processes that are happening. We're printing the week numbers, and we're also printing the weekdays, and the week numbers are starting first. So we need to start with those first. So if we wrote that in pseudocode, we might say, for each week of the month, we want to print the week number. Then, for each of those weeks still, we want to print the first letter of the day of the week. For each workday of that week, we want to print that first letter. So that's a general representation of it. How do we implement this in Python code? Here's an example of a solution. We're dealing with 2 loops, and we want 2 lists to handle those loops. In the outer loop, the only thing that's changing is the number 1, 2, 3, and 4, whereas in the inner loop, the values range from Monday through Friday. Since we can automatically generate a list of numbers, we'll use that range function to do that. But we can't automatically generate the first letters of the days of the week, so we're hard coding a list that we can then loop through. On line 4, we create that list, and then we start. Line 5 really corresponds to the first line of our pseudocode above. We start looping through the weeks. Remember, the range function starts with the number on the left and ends at the number 1 less than the number on the right. So this will give us 1 through 4. And the statement that follows prints week and the number behind it. So that corresponds to the second line of our pseudocode. Next, we do this line for each workday of the week. We loop through our hard-coded list of first initials of days of the week. And the final line prints the first letter of the day indented. How does it do the indentation? It's using this escape sequence /t, so that translates to tab when it's printed out. So it tabs in and then it prints the current day. So we go through this, kind of work through it like we're a computer. The first time we get to line 5, we set week to 1. We print week 1. And then for each of the days in our days list, we print the value. So it's going to print tab M, go back up, print tab T, print tab W, and so forth all the way through Friday. Then it'll go back out to our outer loop to the second week. And that's going to update to 2 and print week 2, and then go down to, for the days of the week, looping again. Monday, Tuesday, Wednesday, Thursday, Friday. And so forth all the way up till we get our whole planner printed out. So that's just an exercise in thinking about hierarchical data. You may, in your applications later on, want to loop through all of the records in a file, or do that in a set of files. So you'll have an outer loop that's the files, and the inner loop, which is the records. Or you may want to loop through all of the files in a set of directories. So loop through all the directories, and then inside of there loop through all of the files and perform some process. This lesson gave an introduction to the while loop and for loop syntax. We started out by reviewing the Boolean and code structural components, since all of that plays into how you do the looping. And we covered the range function and OS listdir with a few examples. The next lesson will be on geoprocessing, combining calling tools with looping. So batch geoprocessing just means geoprocesses within a loop. Some additional related topics will be covered in another lecture, such as list comprehension, enumeration, the walk method, and the zip function.